Welcome back to West Virginia, where everything's gorgeous. Okay, are you ready for joke of the day? Of course you're ready for joke of the day because it is the best part of the day. So, what do you call a fake noodle? An impasta. Okay, let's not be fake and let's get into repeated factorization. There's nothing fake about factoring. So repeated factorization mostly occurs in fourth degree polynomials, and basically the gist behind repeated factorization is exactly what it says. You are going to repeatedly factor. In other words, just keep factoring, factoring until you can't factor anymore. Little tip of the hat to Dory from Finding Nemo. Just keep factoring. So in other words, and take these two examples. I'm going to take a look at this first example that says x to the fourth minus 256. And I'm noticing there's only two terms and I'm going, ooh, that kind of feels like a difference of squares. So I'm first going to look to see if there's anything common that I can divide out before I do anything else, because I always do that. There's nothing common to each one of these. So I'm going to head for that double parentheses. This is going to tell me I have opposite signs. One's a plus, one's a minus. Now, I'm going to split that x to the fourth up. Now, technically, I could split it as an x to the third and an x to the first, but it's probably not going to go that way. Because we've said 9 times out of 10, if it'll split evenly, that's the way to go. So I'm going to split it as an x squared and an x squared. Now, that 256 would be 16 times 16. 16 times 16 gives me a 256. I believe that's right. Yes, 16 times 16 gives me 256. But like I said, just keep factoring. Now, let's put a pin in this one and let's take a look at this one right here. That's definitely a difference of squares. So I will split that up into a double parentheses. Again, back sign here is going to tell me opposite signs. And I'm going to split in my x squared up as an x and an x. 16 splits up as a 4 and a 4. And notice here that if I FOIL this, x times x is definitely x squared. 4 times negative 4 is a negative 16. Out here I get a negative 4x, and here a positive 4x. Those do cancel, and I needed them to because I don't have a middle term here. Incidentally, I should have checked this one. X squared times x squared is x to the 4th. Positive 16 times negative 16 is that negative 256. Out here I get a negative 16x squared. In here a positive 16x squared. Those cancel, and they needed to because there's no middle term. So I'm feeling pretty good about this, but I need to check this one. Now, this is what we call a sum of squares. And a sum of squares never factors. Let me go ahead and write that down. Never factors. And let me illustrate why. You'll try to set up this double parentheses for that sum of squares, and you'll say, okay, this tells me same signs. But remember, once you've identified you have same signs, you need to look at your middle sign to tell you what they are. There isn't a middle sign. So we're not sure what they're going to be. So you might take a guess and put a plus and a plus in there. Now this will definitely split as an x and an x. And you're thinking, okay, 16, let's try a 4 and a 4. I don't quite know what else to do. But when you check your outsides and insides here, out here I get a 4x. In here I get another 4x. Those combine to be an 8x, but I needed them to cancel because I don't have a middle term. And I go, oh, that's right. To get them to cancel, I need to have opposite signs. Now out here I get a negative 4x. In here I get a positive 4x. Okay, they will cancel. But notice this. Positive 4 times negative 4 is a negative 16. I needed a positive 16. And I go, oh, all right, let's try this then. Let's make them both negatives. Because now, negative 4 times negative 4 is positive 16. But now I'm going to get a negative 4x and another negative 4x. They don't cancel anymore. That's a negative 8x. So you see, a sum of squares will never cancel. Or no, I'm sorry, not never cancel. It'll never factor. So I'm going to retain my sum of squares in here. I can definitely factor this difference of squares, so this is the correct factored form. Because if I FOIL this, I get back to here. If I FOIL this, I get back to the beginning. And I always need to get back to the beginning. So let's take a look at one more example. Once again, I'm feeling like this is a difference of squares because I have two terms sitting there. So I'm going to first look and see, is there anything common that I can divide out? And there is not. So I'm going to head for this double parentheses. And this here is telling me that I have opposite signs. So one's a plus, one's a minus. Now that 81x to the fourth, 81 splits evenly as a 9 and a 9, so I'm going to go for that. X to the fourth splits as an x squared and an x squared. The 16 splits as a 4 and a 4. Granted, 81 could split as a 27 and a 3. 16 could split as an 8 and a 2 or a 16 and a 1. This could split as an 81 and a 1 for that matter. But like I said, 9 times out of 10, if it splits evenly, that's what you're going to do. Now notice that 9x squared times 9x squared, yes, it is the 81x squared. Positive 4, negative 4, yes, that is a negative 16. And when I check out here, I get a negative 36x squared. And when I check in here, I get a positive 36x squared. They do cancel as I needed them to because there's not a middle term. So I'm ready to take this further, but remember, that is a sum of squares. Sum of squares never factors. We've already established that. So I'm going to carry it down, but this is yet another difference of squares. So I'm going to head for that double parentheses. This tells me opposite signs. One's a plus, one's a minus. Split that 9x squared up. It splits as a 3x and a 3x. Split that 4 up as a 2 and a 2. Now 3x times 3x is 9x squared. Positive 2 times negative 2 is a negative 4. Check those outsides and insides. Out here I get a negative 6x. In here I get a positive 6x. Those in fact cancel like I needed them to. So this is the correct answer. Again, remembering, when I FOIL this, it gets me to here. When I FOIL this, it gets me back to the beginning. And I always need to get back to the beginning. So, hopefully you're seeing that in repeated factorization, you just keep factoring, factoring, until you can't factor anymore. And then you're stuck, and you're done. I hope that helps. Have a great day.